Hello, am I audible? Hello, am I audible?
Yes, ma'am.
Okay, thanks. So we'll wait for a few minutes because people still seem to be joining. So yeah, let's just wait.
Okay, sure.
Good afternoon, ma'am.
Yeah, hi, good afternoon. We'll wait for a few minutes, people to join before starting. Okay, I think we can slowly start the class. Okay, so hello everyone. I'll share my screen. Yeah, hi everyone. So my name is Zenia. I have been taking this problem solving classes for you. I'm a astrophysicist at the Indian Institute of Science, and yeah, I use Python in my everyday research, and that's why teaching this course has also helped me to learn more Python and yeah, better improve my knowledge as well. I hope the same has been for you. So this is the last week of this course, week 8, and last week that I'll be taking. Of course, during this course, in between, I had an accident, and last week actually I had a surgery. So that's why I was not able to take classes in between. I think I skipped a few. So I'm sorry about that, but I'm sure that you have access to the other people who are taking the problem solving classes, as well as the many very good lecture notes and materials that are available to you. So I hope that you have been making use of all that. Now you're at the end of the course. So as you know, the title of this course itself is Programming Data Structures and Algorithms using Python. So, not only have you learned some basic things of Python. If you've never used it before, now you know how to write some Python code. But more important than learning, how to write a Python code is learning how to think about programs and how to think about how to approach a problem. When a problem is given to you, there are ways to solve it. There are many ways to solve any problem, multiple ways, in fact. But the main thing is that you have to make use of the fact that you're using a computer or you're using the programming logic to solve it, right? So you have to take advantage of the coding aspect of it. And that's what algorithmic thinking is all about, that you have to actually take advantage of the fact that you are using this programming um, language, right? You're using a computer. As I keep saying, like, to print 100 numbers, you can print 100 numbers using just 100 print statements, or you can use a loop. There is a difference between these two things, and that is exactly what we'll be looking at today. Okay. So this last lecture is kind of like you saw a lot of different programs like this grid paths and longest common subsequence, matrix multiplication. These are all examples of memoization and dynamic programming. Finally, also saw what is Python versus other languages. So this is the most important slide to me because I show it in every class. But basically, I would say that whenever you code, try to code in such a way that you are not only a, you can be a coder, but you should be a good coder. And to be a good coder, follow some good coding practices, like following some meaningful variable function names, using comments, indentation, all these things, and being consistent with it. Okay, because as I said, whatever program you're writing today, 1 year from now, if you look at it, you shouldn't be confused as to what this program is doing. Or if you give it to a total stranger, they should be able to at least tell what this program is doing, what are the different variables in the program, what are they doing, etc. So for that, it's a good thing to, if you are always able to have some consistent coding practices. So give nice file names, comments, etc., so that you are consistent with your code. Now, this may seem like a very small thing, but trust me, it helps you in the long run. Okay. So, dynamic programming is essentially when we break down a program into smaller pieces, right? So, we kind of thought, you kind of already have done this, right? For example, when you wanted to find the greatest common factor between two numbers, that's the program that we started with in the very beginning of the class. That time, what did we do? We had this dynamic programming where we first found the factors of each of the numbers, then we are checking the common factors between them. So essentially we are we are breaking down the problem of finding the greatest common factor into first finding the factors of each of the numbers, for example. Or when you do a recursive program, that is kind of the opposite, right? Because in a recursive program, instead of breaking it down to smaller pieces, we just try to take the bigger picture and then try to break that down into the smaller pieces. So yeah, so basically in dynamic programming, we try to solve problems by breaking them down into overlapping sub problems and then storing the results. So that means that we don't have to, for example, in the factor program, we can write a single function to calculate the factors of number 1 and 2, and then we can just call it. So we don't have to again write the same code again for calculating the factor, right? So that is kind of the idea of having a dynamic program. So apart from this, you also have this memoization. Memoization is where you basically store the results of function calls and reuse them when the same inputs happen again. So this is kind of like, for example, this Fibonacci code kind of thing, where you can see that Fibonacci code, how numbers are coming or whatever it is. So yeah, so point is that you keep storing the results, intermediate results of expensive function calls so that you can call them later. Instead of computing it again and again, you instead store it. So these are all the things that you've already been doing. They just have some particular special names, which I'm just listing for you. And you have already been doing this without realizing it or not, is that if you want to be a very good programmer, you will be automatically be doing these things. Like when I want to find the factors of the number, you saw the many different ways in which we did it, right? In some cases we stored the entire thing, some cases we did not, and so on. So this is the idea between memoization and dynamic programming. So you saw some programs this week. One of them was this grid path program where you were given two values m and n representing some metrics, and you were wanting to find the number of unique paths that went between the topmost cell and the rightmost cell. So this is called the grid path program. These programs are all available to you in the notes or whatever. So please look at it yourself. I'm just going through like what was there before. Then, what is the longest common subsequence? So, for example, in a string and another string, what is a common substring basically? So, here, for example, between secret and secretary, secret is the longest substring. Here, you can see that BCD, AACD, and ACD, BAC. The common substring is, of course, it is CDAC, which is coming here. That is CDAC. Yeah. Yeah, so CDAC, right? Yes. Okay. So, right. So this is the common subword. Matrix multiplication, I think we had already looked at, which is basically, yeah, how to multiply two matrices together, which you know this from your mathematics. For example, when I multiply two matrices, this C1 is equal to A1 B1 plus A2 B4 plus A3 B7. C2 will be, A4 B1 and so on. So you have to do, sorry, A1, B2, like that. So you have to do it in that way, like row times column, row times column, row times column, then row times column. Element wise, you have to multiply them and add them together. So, coming to the aspect of why Python over other languages, so I told you some of you already have some experience with other languages, so you'll be able to appreciate it. But even if you don't, I would say that Python is a very good language to learn as your first language. It has many different advantages. So, for example, it's very easy to code in Python because it's a high level language, it's developer friendly. It can be developed and executed on various operating systems. It's object oriented, it's free, open source. So we already have seen many examples of this. But in Python, since it's free and open source, anyone can download it, and anyone can, more importantly, you can see that people have developed so many different Python packages, right, for the different needs that they have. So as I said, I'm an astrophysicist, so there are many astrophysical Python packages like AstroPy, which have been developed especially for this purpose of dealing with astrophysical files and so on. So, different kinds of, so for example, the common ones are NumPy, SciPy, which we use, like NumPy is used for dealing with matrices, SciPy is there. You have various packages for dealing with images or CSV files, or you have math. There's a module called math, which deals with different math operations. You have matplotlib, which deals with graphing, which is very useful to me. I think that's the one I use the most. So, you have this. One other thing is that Python is a such a programming language where, as I said, the syntax is very minimal in the sense that you don't have to have so many braces. There is no explicit type initialization you need to do. So in most of the languages, you have to declare a variable as a particular type, like it's an integer or a float or string before you use it. In Python, that's not necessary. And in fact, in between a program, you will see variable can be changed from string to float or whatever. But this is, of course, as I've said many times, this is a little dangerous because you have to be careful that you don't, what can I say? You don't make any mistake with the uh, if you are going through a particular program, then you shouldn't make a mistake that by mistake change the type in between. So you have to keep track of it. So in that sense, it's also not a very good thing. Can have both the sides, right? In that it's a good and a bad thing, which is that you have to be a little more careful because the program doesn't care about the type or data type of the variable. So you have to take care of it yourself a little bit. Okay. So this is the idea behind Python and other languages. So today I have brought some interesting programs for you, so we can start doing that. Already you have, as I said, solved some many programs in the class. I didn't want to bring these again because these are already discussed by the professor in the lectures. But let's try to do these programs together today, and from that we'll see how things go. So if for that any questions or comments, you can see. How are you? Okay. Yeah, I'm fine now. I had an operation last week, so kind of recovering and going back to normal, but I'm better now. So anyway, that's why, as I said, we had to skip a few classes in between. But yeah, since it's the last class, I wanted to take it and leave you guys with some more interesting programs if possible. Okay.
Ma'am,
So
yeah, before you go to the program, just small question. Like you said, uh, you know, uh, we can change the type of a variable from int to string or string to int or any other during the program anywhere. But let's say, for example, by mistake, if we did so, like we used a variable which was int and we did some calculations there. By mistake, we changed it to string. Then what will happen to the reference of that, variable? Will it overwrite all the calculations which we did earlier? How will it impact?
So at that point, it will not be able to do the operation you're talking about. It will throw you a type error, basically. So we can see this in action. So, okay, so I'll just open the size one some other calculation. So, okay. Suppose I have A is equal to 5 and I do A into equals to, then A is now 10, right? Because A into equals to means A is equal to A into 2. Now, if I give the same A somewhere in the program, I make it A, B, C, D. Okay, that is allowed. Now, if I try to do A into equals to, then what happens? Okay, so somehow it works. Let's try to give it something else. A plus equal to, I didn't know that was a function in Python. So A plus 2, just let's give A plus 2. Yeah, okay. So yeah, it cannot do that because it cannot concatenate string to integer or whatever. If I give it into 2, somehow A into 2 works. I don't know why. A divided by 2 works. No, okay. Yeah. So here, for example, you can see that type error comes. It cannot support. So basically, A has been now rewritten to be a string, right? It's now ABCD. If I say A, it means ABCD. So if I now try to divide it by 2 or something, it will not allow me to do. So that's why I said you have to be careful in your program. Suppose you have a very long program. Initially you had declared something as some integer, you did some calculations, and later by mistake you use the same variable name to have some string value. Then later if you try to do the integer calculations on that, it's going to throw some error, or if it doesn't throw error, it's going to give you some nonsense like this, right? So you have to, that's why I said that in C, for example, if you try to do that, it will not let you do that. It will say that this is an integer, how can you give it a string value? But Python doesn't do that. Python will allow you to overwrite it with a string value. So in that sense, you have to be the one who is mindful that what are the variable names that are there in your program, what are the values it takes, and what are the data types it takes. So you have to be a little mindful about it. That's what I wanted to say.
Yeah, thank you, ma'am.
Okay, good. So yeah, so Python programming, as I said, two things. It's easy in the sense that there's not a lot of extra frills, but it's also having this one drawback. That is kind of, you have to be mindful of program. That is a good tip to have, regardless of whether you're in Python or not. Okay, so now let us do some programs. So the first program is from last year's programming course, and it's a little long program. So let's try to first understand it completely. I'll give you a few minutes. You can try it also, and then we can discuss the answer together. Okay. So a little long program, but the solution is not. The solution is also a little different, but let's try to understand it together. Okay. So this is from last year's Python course, the same course, this code program. Okay. So, okay, fine. So there is some training camp, okay, which has degenerated into blah, blah, blah. There is a lot of tests. Okay, basically, you imagine that there is a training camp that is going on, and in this training camp, we have a lot of tests. Okay, some of the tests have, or all of the tests can also have negative marking. At the end of the camp, each student is evaluated based on the sum of the best contiguous segment. That means no gaps of marks in the overall sequence of tests. Okay, that means if I have 5 tests in my class, then test 1, test 2, test 3, test 4, test 5, which is the best marks I get from the longest sequence of the marks. So I cannot take 1, 2, 4, and 5. I have to take 1, 2, 3, 4, 5, 1, 2, 3, or something like that. Okay, so students have asked for some relaxation. So the camp coordinators have agreed that students are allowed to drop up to a certain number of tests while calculating their best segment. So that is what is given here is an example. So for example, suppose that there is a student called Lavanya. She has 10 tests like this. Okay. So obviously, if I look for the best sequence without dropping any tests, if I consider all the marks she got and I take the best sequence. So again, I cannot just take the best 5 marks or whatever. I have to take the best sequence of marks. So it has to be a continuous number. So in this case, you can see that 5 to 7 gives me the best segment because that gives 6 plus 10, 15 minus 16 minus 1, 15. Okay. In all other cases, the minuses are too high and they will reduce my mark. Okay. So you can see that if Lavanya is allowed to drop up to 2 tests, then the best segment becomes 1 to 7 because I can drop minus 7 and minus 5, test 2 and test 5, which yields a total of 24 marks. If she is allowed to drop up to 6 tests, then the best is taken by taking the entire list, then dropping all the negative. Oh, am I back? Hello. Showed that my internet. Okay, I think I'm back. Fine. So the point is now there are two numbers involved, right? There is n test marks. Here n is 10, where the student has scored some score in each of the tests. Then the second thing is I want to take the best continuous segment and I'm going to allow the student to drop up to k marks, right? So for example, I say that, okay, you can drop up to 6 tests means she can drop all of her negative marks, there are 5 negative marks. If she drops all of them, she gets the best total, right? So for similarly, if I say, okay, you can drop any 1 mark, then she has to calculate the total in such a way. So maybe it will be this 3 minus 7, 6 minus 1, 10. She can drop minus 7 and she can get 3 to 7, the best 5 marks, right? So this is the idea. So there are two numbers involved. One is n and one is k. N is the number of test marks. K is up to how many marks you can drop from the sequence. So you can already imagine that there are a lot of totals that you can have, right? So many permutations and combinations. First of all, you have the each sequence in the number. Apart from that, you also have each sequence with certain number of drop in the thing. So your program has to calculate what is the best sequence for a student given n test marks and k can be dropped. So for this case, this is the solution hint basically. You consider I to be between 1 and n, j to be between 1 and k. You have some array called best of I comma j. Okay. So here you are this is a two-dimensional array, right? So you can think of it like a matrix or like a grid. So here the ith position is basically tells you that the maximum segment ends at position I. So if it ends at 5, then that's best of 5 is basically whichever number is ending at 5 in this case. And with at most j marks drop. So j is the number which controls how much. So best of I comma 0 is the classical maximum subsegment or maximum subarray problem. For j greater than 1, you have to inductively compute best of I comma j from I comma j minus 1. The first line of input will have n and k, following each of them will be the marks, and the output will be a single number, which is the maximum marks from this. Okay. So do you all understand the problem? I cannot explain in Hindi, I'm sorry. Do you all understand the problem?
Yes, ma'am.
Yeah, okay. So you understand, right? I'm going to ask you to take two numbers. One is n and k. N is the number of marks. K is how many marks can be dropped. Then you have to enter all the n marks and then write a program such that it calculates a maximum subsection. So this is a little difficult, I can understand. I want you to take a few minutes to think about it, and then let's go to the solution together. If you do. Okay, so I'll give you a few minutes just to think about the program. I'm just going to show you the this screen so you can understand what's happening. Okay.
Okay.
Okay, we can slowly start looking at the solution. Does anyone want to tell me how you would approach this problem and how you think about this problem? So, as you saw in the hint, we have to kind of create a grid, right? And then we have to calculate all of the possibilities, because now we have all the subsequence which is possible, and then we also have the subsequence with dropping, right? So dropping also is up to that value. So it can be even, we have to keep seeing what is the maximum value. So that's why it's better to have a grid. That is what this best is going to be. So let's see how it looks like. I'll just take the code. Okay. So first of all, we are reading N and K. Oh, sorry, right? And then we have marks. And then we're initializing best. So best is going to be, as I said, it's going to be a 2D array. And so it's going to be a grid where we have J is going to be your columns, which are going to be, you know, for each of the drop values. So if I can maximum drop 5 marks, that means I can drop 1 mark or 2 mark or 3 or 4 or 5. So that's what each J represents. I is going to be a number of marks, right? So we are going to first have the initial base case to be marks of 0, the first mark itself. And then we are going to calculate answer. And then we are going to just update the array based on that. Okay. So first of all, we are just going through the array and just updating the first row. The first row is just without dropping anything, right? So that is what this looks like. So you can see here. Best of I comma 0 is a classical maximum subsegment or maximum subarray problem. So that is exactly what this first row is kind of giving us. Or first, actually, this is the first column. Sorry. So this is basically just the mark itself. The maximum mark of, the first mark, whichever is there, we are just going to enter that. Then we are going to check by adding to this mark each of the marks. So you can see that this is the normal maximum segment. So this is just finding the maximum segment. So it's kind of like this problem which you have done in the class. Right, this was with strings, of course. We were looking for what is the longest common subsequence. So here, instead of looking for the subsequence, we are actually looking for the segment with the most sum, right? So it's a similar kind of idea, but here, instead of just taking the sequence, we are taking the sum of the sequence. Okay, so here first row is just going to be that again. Okay, so that is what is given here. You can see that best of I comma 0 is maximum of this plus whatever is the marks, and the answer is going to see. So you're just taking the previous grid point, and then you're adding on the next one, and then you're checking what is this. So here you're not dropping any value. So you're just keep on adding, and then you're just taking the sum, and that is actually going to be your answer. If you want to find the maximum segment with dropping, then again you have to go to j is equal to k plus 1. So here you can see that you're actually taking you're checking if adding gives you a higher value, or if just keeping the previous value gives you the higher value. Because basically if it's a negative value, then if I add it, that's going to reduce my sum. Whereas if it is not a negative value, then adding will not do anything, right? So adding or not depends on whether it's a negative value or not. That's why I have to take the maximum between adding the marks or just keeping it as it is, the previous value. So whichever gives the maximum, that will only give you your answer. So answer keeps getting updated based on what is the newest I comma j that I have. So finally your answer is going to be the maximum. So if you want to see the entire grid, you can just print out best, and that will actually give you the entire. So let's try to do this with the example that they gave itself. Right, so n is going to be 10, and they said, let's give 0 and see. Okay, so marks are 6 minus 5, 3 minus 7, 6 minus 1, 10 minus 8 minus 8 and 8. Okay, so this is your best array. because I don't have any k, right? So that's why it's just one column long, one row long. If I had k also, then there'll be other rows which are other columns, sorry, not rows, columns which are corresponding to each of the dropping cases also. Here I don't have that. So you can see that each of the values corresponds to adding up, right? So the first one is 6. Second one is 6 plus minus 5. Third one is 6 plus minus 5 plus 3. Fourth one is 6 plus minus 5 plus 3 plus minus 7, which gives you minus 3, and so on. Okay. So you can see how each of them are coming. Okay. So this is how you think of it. And then, of course, at some point, if adding is giving you a smaller value than just keeping the number itself, then you start off new. So, for example, 6 plus minus 5 is 1, 1 plus 3 is 4, 4 plus minus 7 is minus 3 plus 6 is 3. Correct? But 3 is less than just having 6 itself. That's why here it starts afresh from the new number. If you can all follow me, I'll just try to repeat that once more, which is that there are two things. Okay, one is that we want the longest continuous sequence. So now I'm not talking about dropping, I'm just talking about the longest continuous, sorry, not longest also, actually the maximum value of the continuous sequence. Okay, it's related to your longest sequence that you did in the class, so try to relate it, but here you're taking the sum. Okay, so there are two things. One is that I have to keep adding the numbers and I have to see which is giving the largest number. But I don't have to start from 1 every time, right? So here, for example, 1 plus 2 is 6 plus minus 5 is 1. 1 plus 2 plus 3 is 6 plus minus 5 plus 3, which is 4. 1 plus 2 plus 3 plus 4 is 6 plus minus 5 plus 3 plus minus 7, which is 9 minus 12, which is minus 3, right? If I add 1 to 5, then I get 12, 15, 10, 3. I get 3 as the answer. But 3 is smaller than just taking 5, right? Just taking the fifth element, which is 6. So that's why instead of taking all the sum of all the 5 numbers, I will just consider this. So every time, this is exactly what this particular thing does, right? It takes maximum of best of I minus 1, 0 and 0 and plus marks of I. So if the total sum itself is going to be negative, then that's definitely going to give me a sum which is smaller than my original number. I rather not add it. That's why I'm comparing with 0. If 0 is larger, that means that the sum is negative. And when I add it back to the marks of I. So that's exactly what's happening in the fifth element. Instead of adding all these numbers and getting a number which is smaller, I am just keeping that number itself. Okay. Similarly, the next one, I'm just going to start with this element now because I don't want to keep adding this. This is going to anyway give me a negative contribution. So I'll just consider 6 minus 1 is 5, 6 minus 1 plus 10 is 15, 6 minus 1, 10 and minus 8. If I add, that's 16 minus 9, which is 7. Then if I add these four numbers together, then I get minus 1. If I now add minus 1, when I compare adding minus 1 to 8 or just keeping 8, I will prefer to just keep 8. So that is exactly what's happening here, is that this is, by the way, this is without dropping anything. I'm just taking the subsequences and I am adding. And every time I add, instead of just adding like that, I compare with 0. Because if this overall sum is going to be negative, that's going to give me a negative contribution to my sum, and that is not going to help me to get the highest total mark. So at any point, if the previous numbers are going to add up to a negative value, I'd rather not consider it. I will start from the first value itself. So this is the idea, and this is how to find the maximum segment. So now we found out how to do it normally. Next, we will check with the dropping. So does anyone have any doubt in this? Okay, you can. One thing I will say is I know it's difficult to explain when I'm just talking like this. I myself can find it a little difficult to understand. So whenever you write a program, especially a complicated program like this, not only have your laptop, but always have a pen, paper and a pen. Okay, and you here I'm just explaining by talking that there's a grid, etc. But actually you should draw the grid by yourself and mark I, J and write the values. Then it will be very simple to understand. Okay, so try to have a pen and paper with you whenever you do this kinds of programs or any kinds of programs. A good idea that every variable in your program will have some range, right? Usually, so try to solve it at least for a few cases. If your program has a lot of cases, it might be difficult to write down all the cases. But in such cases where, I have 10 numbers or so on, I can just write it down myself, right? So like write I is equal to 1, 0, 1, 2, 3 until 9. J is equal to 0 in this case, so I don't need to worry about J. Now, if I take the sum of the first element, sum of the first two elements, sum of the first three elements, is it easier to take, is it larger if I take sum of first three elements or only consider the third element? So these are the kinds of questions that you have to think about, okay? So I know it can be a little difficult to understand. This is a little difficult program, but I want you guys to listen now. Try to take a pen and paper and work this out yourself also. Okay. So now let's see. Now I'm going to allow dropping of K marks. Okay. Till now we have not gone to that aspect. We have only checked without dropping anything. What is the value look like? Now we are going to have this dropping of K marks also. In that case, where is my thing? In that case, what happens? Then in that case, I have to not only consider I minus 1 j plus the marks, and I have to consider I minus 1 j minus 1, which means either I consider the adding up to the previous element, or I just consider the previous sum. For example, here, let's try to do it with the same kind of thing, right? Up to two tests, the best segment is 24 marks after dropping 2 and 4. So let's see if we get a similar thing. So let's in case now 10 and 2 marks. I will enter the same marks given in the example. So there's 6 minus 5, 3 minus 7, 6 minus 1, 10 minus 8, minus 8, and okay. So now you can say, okay, this is probably not the best way to print it. So let's just say print wait. Okay. Sorry guys, one second. I'm just writing it on hand. So 10 into 6 minus 5, 3 minus 7, 6 minus 1, 10 minus 8 minus 8. Why do you why that didn't work? Okay, good. So this worked. Okay, sorry about that. So here you can see that I have the rows which are each of them, I have now the rows and I have columns because I have drop or not drop, right? Previously I only had this alone. This first column alone I have. Now I have if I'm dropping one element, then I have if I'm dropping two elements. Okay, because maximum of two elements I can drop. Okay, so first column should be familiar to all of us. It is just the max, the for previous one which we just now calculated. That the first element is 6, then it's 6 plus minus 5, then it's 6 plus minus 5 plus 3, then it is 6 plus minus 5 plus 3 plus minus 7, which is minus 4. Then it is adding, sorry, minus 3. Then it's adding all of them, then realizing that 6 is higher. So we are just going to start over from 6 and then going on. Okay. So the first column is just when there is no elements dropped. The second column is when there is a single element which is dropped. Okay. So when a single element is dropped, let's look at it side by side, right? Can we do this? Sorry, one sec. Yeah, okay. Great. So here let's look at it. Now 6 plus minus 5 is 6. First element is of course 6. Second is 6 plus minus 5. 6 plus minus 5 is 1. But it's higher if I just drop this element. So that's why it remains to be 6. Similarly, 6 plus minus 5 plus 3 is 1. But if I drop minus 5, that gives me a higher value, which is 9. 6 plus 3 is 9. So that is what this basically, this sequence, this second column is when we drop elements, right? When we drop a single element, that is what we get. Okay? Just give me 1 second. I just have to take one medicine. Give me a second, okay? Yeah, sorry about that. I had to just take the medicine. Okay, so as I was saying, okay, so there are two things here. One is that we have to take the sequence of numbers. Second is that we may be allowed to drop certain number of numbers. So the first column in this matrix is when I cannot drop any number. So that is what I get. That is the first case that I explained to you guys. The second column is when I can drop one number. So let's compare it here. So first of all, we have 6. Then we have 6 plus minus 5. 6 plus minus 5 is 1. It's better to just drop minus 5 and just keep 6. And that is exactly what happens here. Similarly, 6 plus minus 5 plus 3. 1 plus 3 is 4. Better than that is to just drop minus 5 and keep 6 plus 3. And that is why I get 9, right? Then 6 plus minus 5 plus 3 plus minus 7, that is going to be 9 minus 7 is 9 minus 12 is minus 3, but it's easier to just drop minus 7 in that case and keep 11 minus 5, which is, sorry, not 11 minus 5, 9 minus 5, right? 6 plus 3 is 9, 9 minus 5, which is 4. Similarly, if you calculate the next value, you will see that 6 plus 6, 12, 12 plus 3, 15, minus 5, 10, minus 7, 3, right? So it's easier to drop minus 7. I mean, it's better for us if we drop minus 7, then we can get, what do we get? We get 12 plus 3, 15, minus 5, which is 10, right? We take the sixth term and so on. Because at some point you will see that it's better to start from some other value. Okay. So like that you can check, and this is what you get when you drop only one element. When you drop two elements, similarly you can calculate. Okay. And as you can see, they said that 24 is the best mark, and you can see that in this whole grid, 24 is actually the highest mark. Okay. And that is how you calculate. So the point is that to solve this problem, what have we done? It seems like this very complicated problem, and it is quite complicated. But what we did is we made a grid of all the possibilities, right? So that we don't have to just focus on finding the best possibility, which we don't know in advance. Instead of that, we made a grid. We found all the possible values through the grid. Then we just have to identify the maximum value in the grid. So this is an example actually of dynamic programming, because you are now breaking down, finding out what is the best out of all n and k, to first finding out for n and 0, or 1 and 0, then 2 and 0, then 3 and 0. So you're making a grid. When you make a grid, every point on the grid is itself another calculation, right? This is what I mean by dynamic programming, right? To, instead of solving the problem at a whole, which seems very complicated, we solved it by saying that this is n into k problems, right? Each of this is a different problem that we have to solve. N into k problems are there. Let me calculate each n into k, each n and k combination for 1 and 0, for 1 and 1, for 2 and 0, 2 and 1, etc. Then I'm going to find the maximum of all of them. Okay. So this is the idea behind dynamic programming. This is the idea behind this program also. This grid-based approach you'll find in a lot of programs, and it's also a very, it's a very human way of doing it, in the sense that we will feel like writing things out in a grid and seeing how different values interact, right? So this is something that you should carry with yourself, is that, as I said, while programming, even though we're doing everything in the computer, carry with you a pen and paper, try to write it down. Especially these complicated programs, it will really help you out. Okay. So this is the first program I wanted to discuss with you guys. Any doubts? I know it's not very easy to understand. It's a little complicated, but I would say that, as I did now, we just have to break it down into pieces, so solve it, then compare with the case that you have and see if you can understand it. Okay. So this is the idea. Okay. Fine. So let's go to the next program. If before that, if there are any doubts, I can clear the doubts. Yeah, I don't think there are any doubts. So let's go to the next program, and we'll see. Okay. Okay, next is also a very interesting program. It's also a somewhat a grid-based program, I would say. So I'm going to give you some time to try this out as well. So the Levenstein distance, it's named after this Russian scientist Levenstein. It's known as the edit distance, is a measure of the difference between two strings. It represents the minimum number of single character edits, and single character edit means three things: insertion, deletion, or substitution, which is required to change one string to the other. Calculate the Levenstein distance using dynamic programming in Python. So let me give you an example. We can go to this blog and I'll show you the example. I think it's open here. Yeah, yeah. So for example, you can see here, if you give two words, hello and hello, the Levenstein distance is 0, because to convert one word to other, we don't have to do any changes, right? So if I have two words, hello and HELO and HELLO, then there's a missing character. So I need to do one change, which is an insertion. So there are three actions that I can do. One is insertion, the other is deletion, and the other is substitution. So any of these means I have to give one action. So here I have to do one action, because the distance between them is basically how many actions I have to do. Here the distance between the two words is one action, which is basically, you can see that just inserting this letter L. Okay. Similarly, if I have these two words KELO and HELLO, right? Hello and hello, then we need to first change, we need to substitute K for H, and then we also need to substitute, we need to insert L. So there are two actions. One is substitution of H and K. The second is insertion of L between in this fourth position, right? So that's why the distance is 2, because there are two operations applied. Similarly, if I consider KEL and HELLO, then we must first replace K with H, add a missing L followed by an O, so the distance is 3, right? So this is how we are going to do. Now, instead of, just doing it by looking at the number, of course, when we as humans do, we can just look at the words and we can say that, okay, HELO, there's a L that is to be inserted. But for computer, they have to check all the different configurations, then only it is possible, right? So this is where dynamic programming and this metrics or grid-based approach comes in. So please try doing this first, or think about how you're going to do this. Again, we have to make a grid. Similar to how we made a grid in the previous example, we have to make a grid here also. So I'm just going to give you a few minutes. You please look at it and try it yourself, that how you tell a computer how to find the Levenstein distance between two words. I hope you understand what Levenstein distance is. Basically, how many actions you need to make one word into another word, and the action is defined as either inserting, deleting, or substituting. In exam also, will they ask to write a program? That I'm not sure. As I've said many times before, I am an external expert, so I'm not really in charge of looking at the what is it called, the exam or anything like that. Best would be to ask the exam coordinators yourself. Okay. Okay, so I'll give you some time. Please check it out. I'll give you the program. Okay, I'll try to show you the solution. So first, let's look at the logic together. Okay. Um, so I've linked to this page in the PPT. You can also find it. But basically, what we are going to do is we are going to, again, as I said, dynamic programming is all about breaking it down into smaller pieces, right? The previous case, to solve the problem for n and k, we broke down into a grid of n, all the possible n and all the possible k, and took their combination. Here also what we are going to do is we are going to break, so they have taken these two examples, KELO and HELLO. We are going to break it down into two possibilities, which is that it can be K, KE, KEL, KELO. So there are four possible words we can form from this. Or hello has H, HE, HEL, HELL, HELLO, five possible words, right? So we create a matrix with 4 rows and 5 columns, or 5 rows and 4 columns, whichever you consider in whichever direction. So like this, we are going to consider. Okay. So starting with the first word in the prefix or the first letter in the word kello, which is K, we'll compare it to all five prefixes in the word hello. The first will be H. What is the distance between K and H? It is just one, because all we need to do is substitute the character K by H. So there's only one action. Now we move to the next prefix in hello, which is HE. So now we are going to compare K with HE, right? So now K and HE, if we compare, then we'll see that 2 is the distance, because first we need to substitute K for H, and then we also need to insert an extra letter, which is E. Okay, so that is exactly what's given here. Now the third case, if I take K and HEL, again if I do, again I have to substitute K for H, I have to add E, I have to add L. So there are three actions which are done. So like this I continue doing. So the first row are simply 1, 2, 3, 4, 5, because in every case I have to I have to substitute and add an extra letters. Okay. Now the first distance is 1, because the first two characters in the first two prefixes don't match. If the words were HELO and HELLO, then the first two letters would have matched and the distance would have been 0. In that case, we would have got 0, 1, 2, 3, 4. So again, these look very complicated when it's written out like this, but when you write it down in a piece of pen and paper, it becomes very easy to understand. Okay. So now we have basically, let me just skip ahead. We have checked what is between, say, K and H, K and HE, K and HEL, K and HELL, K and HELLO. Similarly, E and H, E and E, like that we have to check, right? Oh, sorry, not E and H, KE and H, KE and HE, KE and HEL, like that we have to keep looking, right? So this is what is called the distance matrix. So that's exactly what we are going to do. So after calculating the distance between the first prefix of the first word and all prefixes of the second word, the process continues to calculate the distance between the remaining prefixes of the first word and prefixes of the second word. So now this is how the distance matrix we are going to prepare. Sorry, one second. Uh, okay, like I was saying, so we are calculating the distance between the words using dynamic programming now. So we are going to fill the matrix. Okay. The first thing is to initialize a matrix. So here you can see that we have initialized matrix of the particular size. And the number of rows is the characters of first word plus 1, number of columns. And this value that represents the distance between is the value located at the bottom rows column. So this rightmost value is going to give me the distance between the two words. Okay, so here you can see this. Just give me a second. 1 second, I'll be back. Yeah, so sorry about that. As I was saying, we have to create this row and column, and we have to now calculate the distance between each of them. Okay. So dynamic programming is about breaking it down. So what we do is we just work with matrices of size 2, comma 2 as shown here. Due to initializing the leftmost column and top row with numbers starting with 0, there will already be 3 already existing element and only one missing element, which will always be the one corresponding to bottom right corner. So basically, we'll be filling it like this. We'll be filling 2 by 2 matrix here, then a 2 by 2 matrix here, 2 by 2 matrix here, like that. So every time we are filling the rightmost bottom right corner, and the final this value which we get here is going to give me the distance between the two rows. So whenever I'm filling like this, I have to basically check the value of the missing element can be calculated according to two options based on whether the two prefixes being compared are similar or not. So either it's going to be if they both are identical, then the value is just going to be the minimum of the three already existing elements. In that case, you see that the two prefixes are identical. Otherwise, because they are not identical, I have to add one. The one is corresponding to some action. That action can be substitution, deletion, insertion, any of them. So in case the two prefixes are identical, there's nothing to do. So no additional cost is added. When the prefixes are different, there is an operation to be applied, which is either insertion, deletion, or substitution. That's why you get an additional cost of +1. So for example, here like this, you keep on calculating, and that's how we get the thing. So here you can see, for example, our question, why we add the additional row and column to distance matrix. Then according to dynamic programming, we get this additional row and column help us to do the thing basically. Okay, so you can see the step-by-step calculation. Basically, additional column, they mean that we have this extra row of 0, 1, 2, 3, 4, 5 and 0, 1, 2, 3, 4. Why to add that? Because then only we'll have a starting point. It's a top-down approach, right? So, sorry, it's a bottom-up approach. So we need to start from some base case, then only we can build it up. So that's why we need this additional row and column in the beginning. So let's see the step-by-step calculation of the Levenstein distance using dynamic programming. So here you can see that the first distance is between the prefixes of the two words H and K. So in this case, the 2 by 2 matrix involved is this. So as I said, this program just becomes calculating several 2 by 2 matrices. So you can see that the 2 by 2 matrix involved in this operation is here. Because they are different, we have to do the difference as the minimum of these three values plus 1. So the minimum of 0, 1 and 1 is of course 0 plus 1 is 1. So that's why we get 1 here. Okay. So now 1 is updated. So this is the current matrix. Now if I want to calculate the distance between the first prefix of the word K and the second prefix which is HE. So if I want to compare K and HE, then again I will take this matrix, right? 1, 1, 2. So of this, again, because these are not identical, I have to add 1. And because I'm adding 1, it will be the minimum of this plus 1, which is 2. Similarly, I get 3, 4, 5. So this is already we had calculated before, but now we are putting it in a matrix form. So after filling the row corresponding to the prefix K of the word Kelo, now we will fill the second row which corresponds to the second prefix KE. So for KE, the label in the second row is just E, but K Even though it looks like E, it's actually KE. Like that, when here I'm comparing, it's HE and KE. Okay, it's not just E. Fine. So yeah, that and all is explained here. So I think if you have any doubts, just go through this page. Everything is explained in a lot of detail. I am also explaining now. So here again, we calculate, for example, here, which is the distance between KE and H using this matrix. Again, if they are identical, it's just the minimum. If they are not identical, I take the three values minimum and add one, because I always have that extra action that I have to do. Similarly, I fill in everything else. Sorry. Yeah. So you can see that like this, you fill in the entire matrix. And then finally, you get this final value. This is only the distance between the two words, which is 3. And this we had found out before itself. So again, this is another one between setting and some sit mg. So you can see again, it's 3. So this is about the Levenstein distance. Okay. So to conclude, what I'm trying to say in the and the program that we saw previously, the common thing is that we are trying to actually solve for a program which seems complicated, in which it is complicated because there's a lot of different cases to consider and compare, right? So in order for us to do it effectively, what is a easier way for us to understand and actually check for all the different combinations and permutations of this program is to make a grid. So in the previous program, the grid was made between the number of marks and the dropping marks, and then we calculated the sum, the maximum sum that can come from each sequence. Whereas in this grid, we are checking the distance between any two parts of the word. So in both cases, we are making a grid, and then at some point we get, once we fill the grid, it's easy for us to then just identify the answer. So instead of just comparing the distance between hello and kello, we are first comparing H and K, then we are comparing K and HE, then K and HEL. So we have divided this program into many smaller programs, right? And that is exactly what dynamic programming is all about. So that's what these two examples are exactly about. I want you guys to go and see this, try to draw the grids for yourself. It will be very useful for you. So let's just look at the program for now. So you can see that already it's printed because all the programs are in the same thing. Levenstein distance is 3. But let's look at how it looks like, right? So we are trying to create a DP table, which is the dynamic programming table, like we saw in the example just now. And you can see that we are filling the first one column with certain values, and we are filling it based on the one that I showed before, which is that either it's, just the previous minimum value, or it is the minimum of these three operations: deletion, insertion, or substitution plus one. So for example, kitten and sitting, what will be the distance between them? K has to be substituted for S, E has to be substituted for I, and we have to add G. So the distance is 3, and that is exactly what is given. So this is the idea between the Levenstein distance program. So let's go to the next program. I don't think there are any doubts. If you have any doubts, you can go and see it in the page also. That page has everything very much explained. I have put it in the slides as well. Okay, so this is the next program. This is the next program, which is write a program using brute force approach for finding all occurrences of a pattern within text. So I don't think this is as complicated as the previous two programs. I want you guys to try it out. I'll give you some time. Okay. Okay, we can look at the solution because there's one more question. I hope you guys tried it out. As I said all the time, like for programming, you have to try it. Before two programs are a little complicated, so I explained right away. But this, I hope you tried it a little bit. So here we are just trying to match where the position of a string is through brute force. We're just trying to find the occurrence of a pattern within a text. So here you can see that uh, the text length and the pattern length, and we are just going to go from 0 to the whatever is the maximum text length minus pattern length, because we are, suppose we are looking for cat within catastrophe, then we have to check three letter words, right? So we are just going to check until text length minus pattern length. Basically, this is the starting index. So then you're just going to extract the substring, compare it with the pattern. I don't think this is very complicated. So here you can see, for example, text of I to I plus pattern length. So this is slicing, which we have done already. So 0 to 2 means it will take the elements starting from 0 until 1, for example, and checking if they are equal. If they are equal, then just print that pattern is found at the index. So here you can see, for example, oh, sorry. Yeah, so for here you can see that, for example, pattern found at index 2, that is just the solution of this program. So here you can see, yeah, ABC, this is exactly found at index 2, which is ABC. Okay, so that is the third program. I think this is a very simple program. I don't think there'll be any doubts. So I'm going to go to the next program, last program for today, which is this. Given an array of positive integers, each indicating the completion time of a task, find the maximum number of tasks that can be completed in the limited amount of time that you have. So here what I'm doing is I'm going to give you, for example, one task is going to take 5 minutes, another task is going to take 7 minutes, and another task is going to take 5 minutes. You have a total of 10 minutes. That means you can complete the two tasks, right? The maximum number of tasks you can complete is two. You can do both the 5 minute tasks. If you do the 7 minute task, you won't have time to do another task. So this is the idea. So you'll have an array of positive integers, each indicating how much time each task takes and the maximum number of time you have to do all the tasks. So that will, from that you have to calculate what is the maximum number of tasks that you can do. So is this clear to everyone? This program statement, is it clear to everybody?
Yes, ma'am.
Okay, just try out this program. I'll be back in 5 minutes. Okay. Okay, I can see there's a question in the chat. Can we apply job scheduling algorithm for this? I'm not sure what is job scheduling algorithm, but if it works, maybe I can search it. If it works for this case, then yeah, sure. As I said, how you do a program doesn't matter. But if you're getting the solution, if you understand the solution, then it's any solution is good. Okay, we can discuss the solution. I hope you guys have done. Again, this is not a very complicated program compared to the other ones. So basically, so here we are basically checking uh, you're going to sort all the tasks because you know sorting is important because as I said, for example, doing a lot of small tasks is easier than doing one big task, and we might still have time left over, right? So we're going to sort it, and we're going to first check if the smaller tasks occupy the time, then only we're going to add the bigger task. So you can see that for time and completion time, if total time plus time, we're just taking a sum, and we are, if it is less than the thing, we are going to continue adding, otherwise we break and return whatever is the task count. So it's a very simple program. You can see here 2 3 1 4 6 and 8 minutes. If I have, for example, 2 minutes, 3 minutes, 1 minute, 4 minutes, 6 minutes, if I have 8 minutes, the total number of tasks I can do is three, because I can do 3 plus 4 plus 1 8, right? So that's exactly what is given. I gave all the programs in one file, so that's it's like this. But yeah, here you can see that number of tasks that can be completed is three. So it's quite a simple program. I think you guys got the idea. So that's all I had for you guys today. So yeah, let me just turn on my camera. So yeah, that's all I had for you guys today. So I hope that this course in general was very useful to you. It's a very nice course, well structured. All the lecture materials are very good and very well accessible. So please look at all of them. Unfortunately, because of my personal situation, I was not able to join and conduct all the classes as I wished. And these last two classes, I know that it was a little different and I had to rush through some things because I also had many other things going on. So I hope that the other problem solving sessions and lectures are useful. And these lectures also, I'll be sharing all the programs and the all the files with you. So don't worry. I will, and all the previous things are also accessible to you. So let me just share the link once again. So this is my website. If you go to my website, if you go to my website, you can see that, for example, here Here you can see that you have the YouTube playlist of all the week's classes. Week 5 I've skipped, and week 7 also I had to skip because of my surgery. But apart from that, I've taken all the classes. The slides of all the sessions are available along with the programs of each week. So week 6 programs, for example, week 3, all the programs, all of them are available. So please, my suggestion is that please don't see this course as a way to get a certificate or a way to just tick off something from your NPTEL thing. Instead, programming is a skill that, as I said, you can keep on using over and over in your life. So please try to see it as that way. Try to sincerely, so through this through my course at least, you would have got at least I don't know, some 20-30 programs. Please try to go through the programs, understand the logic, and try to write it yourself. That is the most important part. Is that, as I said from the very first class, programming is like riding a cycle. You can't ride a cycle by just you can't ride a cycle by reading books on riding cycles or watching videos. You have to ride the cycle yourself. You have to make mistake. You have to fall off the cycle 2 times. Otherwise, you won't learn. So please try to learn all the programs, and not for exam, just because it's good. And these are interesting problems that they have shown you in the class. So try to understand these programs, and I'm sure that at least one of these aspects will be applicable for you for your field as well. So all the very best for your exam. I think we can end the class because I don't have anything else to say. So yeah, all the very best for your exam. I hope this course was useful for you, and I hope that you all continue to use programming in various aspects of your life. Okay, thanks everyone. Bye.
Thank you, ma'am.